Hello all. I thought it would be nice to introduce our chi-square statistic with a little bit of an example here with respect to making sense of epidemiological statistics. Okay, so in class here, we'll be utilizing the chi-square. We went over the tutorial about how to actually utilize that statistic. In this tutorial here, this will kind of explain some epidemiology statistics that we have encountered here across the last year and a half, 2 years here with respect to COVID-19. Okay, there's all kinds of statistics come out and so forth. It's always good for us to really understand what these things mean, okay, and what kind of trends are happening and so forth. Okay, so making sense of epidemiology statistics. Again, we're utilizing the chi-square statistic. This is just a standard statistic that is used in epidemiology. Basically helps us to understand the progress of diseases, the origins of diseases, and so forth. The chi-square statistic itself, as you see here, it will determine if there's a significant difference between groups, and those groups are usually individuals who have been exposed to a particular disease or a condition or a factor, and those who are not exposed. So first of all, we can determine if there's a difference between those two groups. Secondly, we can determine the relative risk that that exposure or condition or factor has relative to the sample size or the group size, okay? Sometimes you have different sizes of groups when you're looking at infected populations versus uninfected populations. So the chi-square statistic has the capability of determining the relative risk. So it kind of takes out the potential bias that a large group might have versus a small group. And then thirdly, we can just get basically a Las Vegas odds on this kind of thing, okay? Odds that exposure or a condition or a factor has on a given group. Okay, so COVID-19, of course, has been amongst us now for far too long. We've taught this class during the entire time, and so what I've done is we've looked at statistics across time. So what we have here is an example of utilizing the chi-square to just determine if there is a greater risk in one group or another. So these are the initial statistics from King County, Washington, nursing homes. This is kind of like ground zero for COVID-19 in the United States on the West Coast. So we basically input the statistics into the chi-square. So what we are looking at here, this is what an Excel spreadsheet would look like. And the numbers here in the green represent the values. Okay, so what we have here are people living in a nursing home who had positive tests for COVID-19 and died, versus people living in a nursing home who had a positive test for COVID-19 and did not die. And then you have the other group, which are not living in the nursing home. Okay, so just to clarify what we're looking at here, we've got 35 deaths in a nursing home, okay, from a COVID-19 positive test. We have 40 deaths not living in nursing home. We have 115 positive COVID-19 tests without death and 447 positive tests without death. Okay, so just so you can understand what you're looking at here with respect to values. When the chi-square statistic is computed, what we look at with respect to science and to determine if something is real or not is this observed alpha. It's called a p-value. Okay, so the p-value in science, let's jump down here. In science, if the p-value is less than 0.05, then our data are significant. Okay, that would mean 95% of the data are true. Okay, so the p-value less than 0.05. If the p-value is less than 0.01, then we say that our data is highly significant. This means that at least 99% of all of the data that we have are accurate and the statistic is correct. Okay, let's look at the observed alpha, or the p-value that was computed in the chi-square. Note here it's exponential notation. So that just means you have many zeros after the decimal. So this number is actually 0.00000050677. So that's way less than 0.01. Okay, so we have highly significant data. Okay, what does this mean? We asked the question at the beginning, is there a greater risk of death of COVID-19 infection associated with living in a nursing home? And these data answer the question with a resounding yes. Okay, we have highly significant difference between living in a nursing home and not. It's kind of like, look at the values here, 35 deaths and 115 survival versus 40 deaths and 447 surviving. Okay, so there's a big difference here. Okay, so living in the nursing home, the COVID-19 positive test had a higher significance with respect to death. Okay, the COVID-19 positive test had a higher significance in death. So that was the first question. Back up here, we determined if there's a significant difference between groups or not, and we just did. We just determined that there is a significant difference between those living in the nursing home and those not. More people dying in the nursing home relative to not living in the nursing home. The next question, we're looking at the relative risk. So what is the risk of death from COVID-19 infection associated with nursing homes? We put in the exact same values. There's just a different statistical computation, and we end up getting 2.841 as our relative risk. Okay, the relative risk is associated with living in the nursing home and death with respect to living in a nursing home. Relative risk is also good because it eliminates the effect that a large group could have on another group. I mean, we have 447 surviving that don't live in the nursing home versus 115. There's a big difference in those values. Look over here in our totals, 487 individuals versus 150. The relative risk computation removes that potential bias. So it says here that there is 2.841 times greater chance of death living in a nursing home if you test positive for COVID-19. In other words, more than 2 times greater chance, almost 3 times greater chance. Our third question that the chi-square gets is odds. Okay, so it's basically Vegas odds. If you're exposed to it or not, what are the odds of death? Okay, so exposed to COVID-19, living in a nursing home, gives us odds of 3.401. This is what we call a multiplier. Okay, it multiplies the effect. So we have a 3.401 times greater chance of death living in a nursing home associated with COVID-19 infection. Okay, so that's your kind of like your Vegas odds. It's like, okay, if I live in a nursing home, there's far greater chance. Okay, we then looked at, then across time, with respect to the COVID-19 statistics and death, we found that people who were overweight or obese were emerging as a more significant group who were actually dying. Okay, so that's what we're going to look at here. We're going to look at the death, basically risk of death. Is there a greater risk of death from COVID-19 infection associated with being overweight or obese? Okay, because the heart disease risk factors started to emerge. Okay, pulmonary function, hypertension, and so forth. These started to emerge as potential, what we call in medical science, cofactors. Okay, now, don't run with this and think that we can exercise this stuff away and that we can use nutrition to overcome all of this, okay? We can't, okay? The point here is that these heart disease conditions are factors that were making the COVID-19 infection worse, okay? Again, I don't want us to think that, okay, I can go out and I can work out. And I can work out, I can improve my physical self, I can improve my immune system, I can eat better, improve my nutrition, and all of that. You know, that will have an effect. I'm one of the first people to support that. However, in this case, we can't overcome it with just exercise and nutrition. Okay, so let's continue to look here at the statistics. All right, being overweight and obese, is there a greater risk? We run the statistic and the p-value comes out to 0. Okay, that's less than 0.01. So we have 99% accurate data answering the question with a resounding yes. It's an extremely high association of death from COVID-19 and being overweight or obese. The next is looking at relative risk, okay, taking out the the potential difference here, like, you know, you can see death cases 400,000 versus only 100,000. Okay, so we can take out the difference there, and we have a relative risk of 3.462. That's 3.462 times greater chance of death from COVID-19 infection if you are overweight or obese. Okay, again, you might be thinking, okay, I'm not overweight, I'm not obese. If I get COVID-19, I can survive. Well, potentially, yes, you can, but you could still not. Okay, you can still have other cofactors that have an influence here. Okay, so in other words, here, risk of death associated with being overweight or obese is more than 3 times greater than not being overweight or obese. And thirdly, with the chi-square statistic, we can get, again, those Las Vegas odds. The odds of death from COVID-19 if you are overweight and obese, okay? And that comes out to 3.531. 3.531 greater times, sorry, 3.531 times greater chance of death in the overweight and obese population. So again, we're looking at a significant effect here. Okay, bringing us up to current issues, current data, and things that are going on in the world now, or at least in the United States now. We're looking at statistical values here since the vaccine rollout. Okay, there's all kinds of controversy about the vaccine. Okay, you know, we're all in school, we're all vaccinated, but there's all kinds of controversy about the vaccinations. Okay, most of it completely unwarranted and unfounded, but that's not the point here. Let's look at cases that have basically accumulated since the rollout of the vaccine, which occurred in early 2021. All right, so we're looking at current cases here of over 9 million. Okay, now these are not all cases that with people in hospitals and so forth. These are the cases that have accumulated across time since the vaccines have been rolled out. Okay, so you've got 9,500,000. Okay, we've got 8,900,000 of those cases were unvaccinated, and we've got 571,000, almost 572,000 were breakthrough vaccinated cases. We then can look at things like hospitalization. Okay, currently hospitalized 14,512, and you can see 13,700 plus are unvaccinated, 726 vaccinated. Okay, so yeah, the breakthrough cases exist. Okay, this does happen, all right? It's the death that occurs, and that's usually associated with something else, as we have just seen with Colin Powell. Colin Powell is 84 years old, high-risk group. He had cancer. Cancer compromised his system, and so COVID-19 mixed with the compromised system from cancer overcame any kind of vaccination that he possibly had. Current deaths from these 9 million cases, 155,000, almost 151,000 of those were unvaccinated cases, and over 4,500 were vaccinated cases. And just in case we need to utilize the US population statistics we have here, and we're looking at also the vaccination statistics versus non-vaccination statistics. Okay, we're only considered the fully vaccinated population because the partially vaccinated population does not count. Okay, people think that it does, but it doesn't. You have to be fully vaccinated for the vaccine to have its effect. All right, let's look at our chi-square here. We're going to look at the 3 questions about cases, the 3 questions about hospitalization, and the 3 questions about death. Okay, what can the chi-square tell us? First question here, is there a greater risk of case of infection associated with being unvaccinated? So we take our numbers that we had on the previous slide and input them into the chi-square statistic, and you can see we come out with a highly significant effect, the p-value being less than 0.01, highly significant effect, 99% accurate in this calculation, answering the question, is there a greater risk of case of infection associated with non-vaccination? Resounding yes. Okay, in other words, risk of cases is extremely high. Okay, we have far more cases in the unvaccinated population than the vaccinated. Okay, let's look at the second question that we can answer here. What is the risk of cases associated with being unvaccinated? Okay, this is the relative risk calculation. Remember, this eliminates the difference here between the 8.9 million versus only 500,000 people. Okay, relative risk calculation at 20.666, almost 21 times. Okay, that's a multiplier. I'm down here. What is the risk? 20.666 times greater chance of hospitalization. Okay, sorry, of case, okay, of a case in the unvaccinated population. Okay, 20 times, 20.666 times greater. Okay, we have more people in the unvaccinated population having having infection, and having cases. Okay, what's the odds? The odds here, just the Vegas odds, almost 22 times that of vaccinated. Okay, so basically the unvaccinated population has almost 22 times greater chance of being infected by COVID-19 than the vaccinated population. Okay, 22 times. Don't know how high these numbers have to get before people think they are significant. All right, so that's just getting infected. Okay, getting infected, you got a 22 times greater chance being unvaccinated. Now let's take a look at hospitalization. Okay, the vaccine, the purpose of the vaccine is to reduce the effect of the disease. Okay, reduce the effect of hospitalization, reduce the effect of death. Okay, so we're trying to really get at that reduction of hospitalization. So here we remembered, we went back, we had 14,512 people hospitalized with critical illness. Okay, 726 of those were breakthrough cases, and almost 14,000 were of the unvaccinated population. We run our chi-square statistic, and look, we get another exponential property here, highly significant data indicating that at least 99% of all that we know, we are correct, answering the question, is there a greater risk of hospitalization due to COVID-19 infection associated with non-vaccination? Resounding yes, the risk is extremely high, okay? That is a highly significant difference. Again, you have to appreciate that this means we are almost 100% accurate, okay? Don't sit here and think like, okay, well, 1% inaccurate. Okay, you can have your 1% inaccuracy and exercise yourself and free think yourself all you want, but you'll never overcome the disease. Second question, what's the relative risk of hospitalization in the unvaccinated population? 1.212, okay? 1.212 times greater chance of hospitalization. You think, okay, oh yeah, it's only one, no big deal. But the point is this progresses. Once you're hospitalized, then it potentially progresses to death, okay? So 1.212 times greater chance of hospitalization in the unvaccinated population. And we actually see the same odds ratio, so the same Vegas odds. Okay, if you're unvaccinated, you have a 1.212 greater chance of being hospitalized if you become infected from COVID-19. The last one here, let's look at death. Okay, death with respect to COVID-19 in the unvaccinated population. The first question, is there a greater risk of death from COVID-19 associated with unvaccinated? And we get a p-value of 0, highly significant influence that being unvaccinated is the reason what is causing death. And now we can go back and consider all the heart disease risk factors and so forth that might be so that usually are associated, and we get a better picture of the patient. Okay, but again, we can't exercise this away. We can't nutrition this away either. Okay, this has to be dealt with by medical science, which we have had the chance to observe across time here. So again, is there a difference between being vaccinated and not in your risk of death? A resounding yes. What is that risk? What is that relative risk? 2.064 times greater chance of dying from a COVID-19 infection in the unvaccinated population versus the vaccinated population. And the Vegas odds come out to be just about the same thing too. Over 2 times greater chance of death. The whole point here is, this is our chi-square statistic. These are the values. These are how we interpret these values. And these directly relate to what we have been witnessing across the last year and a half or so. Okay, so that's your chi-square. Those are your epidemiology statistics. I hope that some of that illustration can help us make better decisions for ourselves in life. And I hope that perhaps that can help us think about these things in a more logical, in a more rational, in a more, at least less emotional way, and just really consider what we face here in life. Okay, thank you all.